In this segment, we're going to be looking at Objective 1.3, which is describe the impact of infrastructure components in an enterprise network. Firewalls, access points, and wireless controllers. We'll look at a couple of other devices in this also, but this is hardware devices. Some a limited scope of hardware devices. So in this, I'm going to start out, and we've talked about the OSI model. A hub and a repeater are devices that you may hear about. Hopefully you're not going to be in a network where you have hubs except for very special circumstances, because remember, a hub, a layer 1 in the OSI model, it was a true bus. And a true bus was that situation where we had a piece of coax and all of our devices were connected to that same piece of coax, and this used T connectors to do that. They're just the coax at each end, and then we brought it into the to the NIC on the computer. We had a terminator, which was a 65 ohm, 50 ohm resistor at the end, at each end of the bus, in order to absorb excess signal. So it's a true bus, which means we have collisions. Remember, we talked about collisions where that if I send my traffic out, everybody else is supposed to be listening to be sure that they don't send their traffic out while mine is there. So we don't want this guy to broadcast in here and then have the collision. If we have the collision, single collision domain, and that's important. Single collision domain. If we do that, if we have a collision, and we have to go into random backoff. Random because if we had a fixed backoff, they just all back off and do the same thing again, and then they do the contention for the media and go through the whole thing again. A repeater regenerates the signal, not an amplifier, and we talked about that. As a signal goes down a piece of copper, it gets smaller and smaller. We're also going to have noise in copper, electromagnetic noise, so that if the signal, if the ones and the zeros get below the noise level, then we cannot discern the signal. What we'll do is, before we get to that point, and that's what the distances are all about in the different types of different media types, and they're all going to be a little different. When we get into fiber, they go a lot farther because they can get a lot smaller before we have to repeat them. So we find our ones and zeros again and bring them back to the original signal strength, and then they go down, lose the signal strength again. So repeater regenerates the signal, not amplifies. If it amplified it, it would amplify the signal as well as the noise. And you may have heard that sometime when somebody amplifies the noise. Not a whole lot of fun. The next device set that we're going to look at is the switch. Switches are layer 2 devices. Layer 2 devices locate the access layer of the hierarchical model, layer 2 of the OSI model. Layer 3 switches are located at the core layer of the hierarchical model. The hierarchical model here is the Cisco hierarchical, which we will do. Just keep that in mind. Cisco hierarchical, if I can spell it. Cisco hierarchical. There's going to be a 3-layer model that we're going to use. And layer 3 switches at the core layer, big deal, going to be high speed devices. And what we do is these things start out as layer 2 switches. We can convert them into something that will forward packets, which would then work at layer 3. I know we're kind of mixing apples and oranges here, but not really. Layer 2 switches located at the access layer, and they create collision domains. So that each port, put a bunch of ports here on our switch, and this is the Cisco symbol for a switch, and this is the Cisco symbol for a layer 3 switch, and this is what a switch actually looks like down here. each of these ports, or we can just go down here, each of these ports on a switch is a collision domain. And they're full duplex. We talked about duplex, half duplex, simplex, which is broadcast, half duplex, transmit and receive one at a time, one lane bridge. Full duplex like an interstate highway. We don't have any collisions. So if we don't have collisions, then we're going to increase our data rate. I've said in a lot of classes that I've done, and this is true, if I can only have one device to be added to my network from the originals, it would be the switch, because it provides so much more to us, provides speed, and we're going to be, later on, we're going to be able to provide some security with it. Provide desktop access to the network at the access layer, and this is again the access layer of the Cisco hierarchical model. The Cisco hierarchical means for segmenting a LAN into VLANs, which we haven't talked about, for a larger campus of LANs, which means that if we had a switch, a bunch of switch here and a router here, and we connect these two switch networks together using a router, we would have a LAN, a local area network here, and a local area network here. What we can do with a switch is create with it a virtual, just like in a virtual computer, a virtual LAN, multiple virtual LANs on it, where they're parts of different IP subnets, and we will do that as we get into the course. Cisco's Catalyst switches, special switches that provide several choices of interfaces depending on the type of LAN, and interfaces RJ45 or fiber is typically what we're going to be talking about for those. The next device is a router, and a router is going to be located at the distribution layer. The layer 3 switch was at the core layer, which is going to be the top, was at the core layer, and it did its routing in hardware. And switches work in hardware, which means they're going to be faster. A router routes in software. So we have an operating system that we install on this thing. This one uses what's called ASICs, which is integrated circuits. But we have software, the iOS, the Cisco software operating system that we load on the router, and then it is optimized for packet forwarding. So it's located at the distribution layer of the hierarchical model. And again, the hierarchical model is the Cisco hierarchical model. Layer 3 of the OSI model, which we've talked about, which means that we're going to have IP addresses here. And remember, it creates broadcast domains. So we're going to create broadcast domains with it, which is going to give us some security as well as eliminate a lot of broadcast traffic or isolate broadcast traffic to particular networks. The larger the number of WAN connections at a branch and remote offices, the larger the router needed to support these connections. What this is saying is, we're doing more work, we're going to need a router that can do more work for us. Let me see if I can get this text on here a little bit better. Okay, so the larger the network, more remote offices, the larger the network we're going to need in order to do that. A wide array of router products, and this is a Cisco ad, but this is what we're about here is Cisco. Varying processor speeds, interface types, densities, and memory capacity. Network models share common interface, which makes upgrading easier and more cost effective. And you can kind of see that here on the back of this device. These are modules, individual modules that we can take out and put in new devices to do that. This has got RJ45. We have some serial connectors here. The newer serial connectors are a little bit different shape. So we can upgrade these things, share common interface. makes upgrading the common interface, common module, so it is a modular device. And we can see down here, these right here have some blanks. These are modules that are not filled, so we could add capability to this device. What you'll find, and we don't have the back of this, this is a Cisco 2950 Catalyst switch on the back. Switches don't have power switches on them like routers do. So the devices, the routers, and the switches. Access point, now we're getting to some of the devices, one of the devices that's in the objective itself. And so I should have done those. I think it's important that we talk a little bit about all of these different devices when we go through here. But an access point, you probably have one at home, provides a connection between wireless devices, can be connected to wired networks, and discover and join the CAP WAP, control and provisioning of access control points. What this means is that in the higher level of access points, we can have a management, we're going to talk about the management of them here in a minute, domain that these things join. So we have a wireless access point here, SSDs, different SSDs that have different capabilities. We have VLANs, the virtual local area networks, on these things, which means that they can only access certain devices later on. We have a WAN router here, it goes to a switch. At some point, remember that a wireless access point's got to connect wired to the network in order to be able to communicate with everybody else. But has a network interface to connect to the wired network, and an antenna or infrared receiver. You may or may not see infrared receivers anymore. To receive wireless signals. So we're going to be wireless on these things. Uses an SSID, a service set identifier, 32-bit alphanumeric stream, and this is what the engineering here. Engineering, guest, and one that I've covered up here, maybe admin, would be the SSIDs. And this is to assist us in connecting to the correct one. You're seeing as you go to out into the world with your wireless device, and you see all the different names show up. Those are the SSIDs. Which ones can you connect to? You know, you go to a Starbucks, that's the one you're going to connect to. Go to McDonald's, that's the one you're going to connect to. Some of them are going to be secured, some of them are going to be open. And I know nothing new, but be wary of open access points. It identifies the WAP, the wireless access point, and all the devices attached to it. Security features enable to specify the wireless devices that can make connections to the wired. We started out with WAP, obviously, and now we have moved up into the security world. And you should have security configured on your devices, obviously. And when you see the little lock, we're going to have that WEP, not the one that we want to use. In today's world, WPA2 would be the preferred. If you don't have that, WPA would be that, and we can have enterprise. We're going to use something like radius servers, and we'll talk about those, how to do that later. To put that type of security on, pre-shared key where everybody has the same one, not a great way to do it. How long can you keep a pre-shared key secure? Wireless controllers. Okay, we've talked about the wireless access point. You and I, if I want to make changes to my wireless access point, if I want to change anything on it, I log into it with the web interface, make the changes to it. And then what I can do, what we do with the wireless controller is control a whole lot of what are called lightweight access points. A lightweight access point is one that we can't open the web interface and do the configurations. It has to be managed by a wireless controller. And that's what this guy up here represents, the wireless controller, which sends all the configuration information to the devices. If you have 2 or 3, not a big deal. You log on to them and do it. But let's say that you have 100 of these things that you have to manage. A really, really large area, a large warehouse or something like that. The fork drivers have to be in continuous contact to find out where to get stuff and where to send stuff as you're packaging and so on. So the Cisco solution provides, let me pause this here again, maybe, and fit this. So let's just see if we can fit this one on a little bit better. That's a lot of my text, didn't it? Anyhow, the Cisco Unified Wireless Network Solution, UWN, 802.11 networking solutions for service providers and enterprises. Cisco wireless LAN controllers, associated lightweight access points. One of the things I always found curious was when you upgrade one of these, and they call it a fat access point, you upgrade it to a lightweight. So we can upgrade what we have to a lightweight access point. When we do that, we have to manage it with a wireless LAN controller. So the LAN controllers, associated lightweight access points, are controlled by the operating system using the operating system user interface, such as a web user interface, command line, or the Cisco WCS, and this is a wireless control server. Simplifies the deployment and management of large-scale wireless LANs, and large scale is the key here. When we have so many of them that we can't configure them individually. Standard wireless policy, we want to change the security policy. For instance, if we had 100 of these things, we'd have to go to 100 devices and change the policy. If we have a wireless controller and the lightweight access points, we modify the policy in the controller, and then it sends the updates to the lightweight access points. So wireless controllers, devices that manage the access point configurations in the firmware, enables faster response to business needs by providing centralized management. In the networking world, centralized management is a thing that people like. The reason they like it is because you don't need as many people. You don't have to pay as many salaries in order to do that. When I first started doing networking, if we wanted to install Microsoft Office, which is what we used on 300 computers, we got our CDs, and all of us that worked in networking went out and sat down and did a double click with the CDs. At the end, if I wanted to install Microsoft Office on the same 300 computers, I simply configured a policy, and when the machine started, the software got installed. So in today's world, probably we need fewer networkers, but we need more educated, more, I would say more qualified, but a more diverse networker. So faster response, simplifies the deployment operations, flexibility to configure the policy management, security settings, and help apply a network-wide centralized security policies across the wired and the wireless network. So we can update, configure them quickly. And this is just an image of a lot of what it might look like in a large deployment. We have our lightweight access and the CAPWEP. These guys were automatically joining the wireless network. Connected, the wireless controller, the WCS, the Cisco WCS, the management station, client browser connects to the WCS, make the modifications, and then we send that information to the wireless access points and update them in that manner. And that third-party server over here is a Windows server, a NetWare server, or whoever's server, I guess a Cisco server, so that we have access to the resources after we do those configurations. Firewall, something that I'm sure you have used. What is it? configured to block suspicious or unsolicited incoming traffic, and it is generally designed to keep people out of our corporate or protected or our trusted network, except for those people that we want to be able to get there. We might have a perimeter, we have a screening router here, we might have a DMZ. This is one of those three-leg firewalls, a DMZ, which would allow anybody access to the web server and the mail server. But then we don't allow anybody to go into our trusted network. Also, as traffic goes out, the requests go into what's called a state table, so that when the answer comes back in, it's allowed to come back through the firewall. Unsolicited, somebody else trying to get into our network to access resources inside of our network. Allow incoming traffic sent as a response to the request from internal hosts, and this is what the state table is called, a stateful firewall. Stateful firewall, which has a state table, which keeps track of the state of the connection. A lot of states there, but what that's saying, as the request goes out, an entry goes into the state table. When the answer comes back, it allows it through. If somebody tries to forge a response, state table says, no, we didn't initiate that, go away, and stops the traffic. Traffic that has been specifically permitted by the systems administrator based on a set of defined rules, and that's what the DMZ here. One of the things that would happen there is, if we're running a web server, maybe we're selling something, we would really like people to be able to get to our e-commerce server. So traffic that comes in, any traffic is destined to this IP address, and the port 80/443, whatever we're using, 80 for HTTP, 443 for secure, is allowed to go to that IP address. Get to the mail server, are allowed to get to that IP address. Complex filtering algorithms, and we'll do some filtering, some access control lists in this one, and more access control lists in the second part. Analyze incoming traffic based on the destination and source address ports, numbers, and the data type. So we can control based on the source, destination IP address, and the destination port, the service. If you recall, we're back to the ports. The port represented a service. Let's try that again. A service, like 80 was HTTP, 25 mail SMTP, and the other ones that we talked about, FTP 20 and 21. So information about the incoming and outgoing connections can be saved to a log, so we can log this information and use for monitoring, hardening purposes, as well as analysis. So who's trying to get, how many people are trying to get into our network that shouldn't be? How many people got into our network that shouldn't have? When did that happen? What configurations need to be changed? So that's a look at the devices. The summary here, the hub and the repeater were layer 1 devices. We have a single collision domain with them. A switch, we had layer 2 switches and layer 3 switches. The layer 2 switch created collision domains. We had a collision domain on each of the ports. We have a 24 port switch. We have 24 collision domains. The router was a layer 3 device. It created broadcast domains, and back to the OSI model, it finds the path to a network to get from point A to point B. Firewall prevented unwanted connections. We used filters called an access control list in order to do that. Access points were used for wireless access, and the wireless controllers were used to configure the lightweight access points. So with that, we'll stop here with this one and go on to the next topic, which is to compare and contrast the collapsed core and the 3-core architecture. So the 3-core architecture that we talked about, the devices on the devices where they were, and we'll do that again. We're going to talk about that architecture in the next one. Hope to see you there.